Welcome to this LTspice video tutorial. In the last video, I showed how to create a new schematic from scratch. We're going to continue and now use this schematic that we created to run a transient simulation. So the two things that you need to do for a transient simulation is, first of all, you're going to need some sort of source, and then you're going to need the transient simulation directive. So to get the source set up, this voltage is going to be our signal source. So we're going to right click on the voltage source, and you're going to get this fairly simple dialog here, and we want to go into the advanced portion. And so in the advanced, you'll have the simple things that were in the previous view, but you'll also have this more advanced view. And so if you wanted to just do like a simple DC measurement, you'd put in a DC value here, and then we'll review these the AC later. For right now, we're going to do a transient, and so just to make it an interesting transient simulation, we're going to make this a pulse input. So for a pulse, you're gonna need to put what's the starting voltage, this initial voltage, what's it going to be after it's at the end of its pulse. So I'm going to say we're going to start with a 0 volt. We're going to go to a 5 volt. And then there's this delay of how long does it take to go from 0 to 5. I'm going to put 10 milliseconds. What's the rise and the fall time? I'm just going to put 1 microsecond. This is something where you want to put something somewhat realistic. But in my case, I want to make some pretty sharp square waves. And then here, I just want to make it, like a square wave where it's going to be on the same time as it is off. So I'm going to say 10 milliseconds on. And then because I want it to be, evenly on and off, I'm going to make it 20 millisecond period. I'm going to leave the cycles blank, which means that I just want that to kind of continue on forever. If you wanted to only, have that go for a number, a certain number of cycles, you could put that here. I'm also going to keep this checkbox on where I say this information will be visible on the schematic. And so now you're going to see the information about your source here. I'm going to move it. So I'm going to use this move button here. Click that. And I'm going to move this over just so it's a little easier to read. In fact, I'm going to use my mouse wheel to zoom this out a little bit as I bring this out. Let's see. I don't know. Maybe I'll just put it here, and then I will use space to zoom back in. So now I've got my voltage set up, and the next thing I need to do is I need to add the analysis directive. So you've got lots of choices here, which again I will go over in other videos, but for now we're just going to do a transient simulation. So you remember I've got a pulse that's got a 20 millisecond period. So I'm going to run this for, let's say, 60 milliseconds. That'll capture 3 of those pulses. The rest of this I'm not going to bother with right now. We're just going to start out simple. And I'll just put this transient somewhere where we can see it there. So now we've got what we need to run our transient simulation. And I'm going to hit this little play button to run my transient. At this point, if I had any sort of errors in my circuit, it will tell me. Hopefully I've done everything correctly. It looks like I did. So I ran my simulation, and now I've got this blank waveform window over here. At this point, you can rearrange if you want. You can move things around. You can stack horizontally or vertically. So now at this point, if you want to plot something, one way you can do it is you can just click on the net that you want to plot. So here, you're going to see the voltage probe comes up. And so I could click right here on this net, and it's going to plot the voltage at that node right there. And so you can see it's my pulse like I was expecting. So if we go and we look at I right clicked on the voltage, and you can see how I specified the pulse. And so that's what we're showing here. So that's one thing you can do to just kind of double check and make sure that it's doing what you think it's doing. And so then I can also probe the output, and I can see that my little RC circuit here is doing what I would expect. I'm seeing an exponential settling right here. as it's, responding to the input pulse. Let's see, something else we can do is we could plot current. So the way you would plot current is you could actually click over a component. You can see, and it'll show you what the direction of the current is that it's going to plot. So let's say for here, I could plot this, the current through the capacitor. So at first it's going to plot it in the same pane, and you're going to get this secondary axis, which is going to show the current. I'm actually going to add a plot plane. So if I right click on the waveform, you'll get add plot pane below. And then I'm going to drag. So if I just drag on the name here, this IC1, and I can drag it down to this other plot plane. So that's, a way that you can organize things based on what you're wanting to look at. I can also plot the current. So if I come back and I click on the schematic window again, I can plot the current in the resistor. Now, one thing you'll notice is, so we've got this circuit where the current in the capacitor should be the same as the current in the resistor, and it is, but it's opposite. And that's because SPICE has a concept of, direction of the way these components have been placed. And so this resistor is placed, in somewhat of an opposite polarity from the capacitor. You can actually look at this in the raw net list. So if you take this schematic and you convert it to a net list, which you would click on the view up here at the top, you're going to click view, and then you're going to say SPICE net list. And so here you can actually see, kind of look under the hood of what the circuit looks like to LTspice. And so you can see that the R1, the directionality is from the output node, or, this net that we called out. So that's pin 1 for this resistor, and then in is pin 2. So the current is going from out to in, and then the capacitor, you can see the current is going from out to ground, which is what this 0 node is. So if you're ever troubleshooting your circuit and trying to understand what you're looking at, viewing the net list is one way you could do that. So if you are picky about this and it matters to you on your waveform that currents are the way you expect them, something you can do here is you can rotate this resistor. So I could move it. So again, I could either move by clicking the move icon, or I could do the hotkey. I'll click M for move. So I'm going to move this resistor out, and then I could either rotate it 180 degrees, or I could flip it. So you can see here, there's the rotate or the mirror. I'm going to click mirror and put it down that way. And so now I'm going to stick it back in my circuit. And then so far, nothing's changed because I need to rerun the simulation. So if I rerun, now you'll see, and maybe it's hard to see because they're overlaying each other. So I can click on the current in C1, and then I can click on the current in R1, and you can see that they're the same. Another way I could sort of prove this out is I could add another plot plane and then just show you. So, so that is just something to be aware of, that there is, sort of a directionality of currents, and if that matters to you. Let's see. So one last thing to show is that you can zoom in, so just like we could zoom in over here, various ways on the schematic, you can also zoom in over here. So one way to zoom in is just to click in the waveform, and you can just click and hold, and you can see I've got this, zoom icon here. And so we could zoom in to the waveform like that. Similarly to the schematic view, you can also hit space to zoom to fit. And then a quick measurement, like if you wanted to just do a really quick measurement on something, you can actually use that zoom feature to do that. So let's say I wanted to measure, I don't know, I'll just measure like the period of my waveform just to double check and make sure I set that up right. So you can use your zoom feature, but don't let it go. And if you look at the lower left, you'll see what the X distance and the Y distance is from the corners of your zoom. And so you can use that to make a measurement just really quickly. There are other ways to make measurements, but this is just sort of the quickest way to do it, and easy for me to show you since I'm already showing you Zoom. So next we'll talk about AC simulation and some other ways to make measurements.